Now we should be live. Hello everyone. Let me just see if, yeah, everything should be live right now. Tell me if something is wrong with either with the microphone or the camera. I think should be fine. Hello Blagoy. I will show you at the beginning of the stream. I will show you. We will just wait a couple of minutes to set up everything. So stream starts in couple of minutes. Just to set up everything, but the whole idea is to be quick and to create a simple game today. Maybe even if we don't finish it, I will upload a version of the game first, like something, or just to host it, and then maybe later. But I want to finish it. I want to finish the whole game because it's kind of simple. There are a lot of implementation maybe just around it, but it shouldn't take us more than 2 hours to do it. It should be a challenge. Okay, so what I will do, so I need a name first. I need a name. So I need to show you what actually the game is all about. Okay, because this is a task from the faculty, so I have a subject called domain specific languages. Let me just check something here. Okay, that should be fine. So because I have a subject called domain specific languages, modeling languages actually, I need to create a really simple game. So what are domain specific modeling languages? There are some languages that you create. So you create like a programming language which is only specific to some domain. And we are going to create a language, but not actually like a whole language. So you have seen these games where I will show you an example because I don't want to draw something. So there are some games that are used to teach children about programming. So if you go here like robot games, you have like some simple games where you need to move the robot to some other square. And there are some advanced games that you like have like obstacles and you need to avoid the obstacles. So in this here, this is like really simple game, right? Like you don't even have for loops, but you have like, so this is like says move to the right. So I have to move to the right, I have to move down, I have to move down, I have to move down, and I have to move. So what is, I'm not sure what there's, you you're supposed to use only 4 of these. Oh, so you're doing right, right, down, down, and then left, right? And then the robot moves and you have to the ending point. So the kids kind of learn like this, and then you have different kind of tests, right? I mean, different kind of situations, and then you have also like also different. You can use for loops and other things. I don't know which games are here with like for loops, but remember we had one like this, but with Minecraft. I mean, yeah. So like there are different kind of games and different kind of things you can invent any kind of game. My idea was to invent something much more complex, even though it's for kids. It still will be based on in this, but it will be based a little bit with a little bit much more complex algorithms behind, right? So it's still we're going still to have like a robot which will move into the dimensional space. But the definition of the game will be, I mean, there are a lot. I actually thought about a lot of variations, and there are some variations that can be made into competitive programming problems, actually. And it could be actually really simple to make, really actually interesting to make a competitive programming problem with some of these variations. So maybe sometime we will do that on Polygon and actually create a problem. But for now, we will keep it simple because we need to implement this game, and I need to implement this game as an exercise for the faculty. But of course, they said like you can implement very uh, uh, so I will tell you everything. Like so they first said you can implement any kind of game here with something like this. So you have like some robot or something. It has to do it has to do some task. And the at the end, what we have to have is some kind of our domain specific language. So something that we can use to command the robot. Some for loops here that we need to put, or for or while or whatever. We can do whatever we want really. Let me show you some more. I don't know if they're like, yeah, you have this like for loop where like you repeat this some number of times, right? And then you have if statement. If this is true, then you have to do this. So, but the idea is to implement such a simple game. Now there are a couple of things for who will be this meant. Okay, so that's a great question. So our game, I will first define our game, and then I will tell you variations, and I will tell you that the first variation will be meant like for kids, and then you can have like an upgrade for other people as well, and actually like you can make really cool interesting things with this. But our game will be very simple and like this. So you will have like you will have a n by n grid. Can I do this? N by n grid, where you will command a robot, right? The robot can move in 4 directions. There are also m boxes on the grid, and one of the variations of the game, which we will call today, but there is another variation of the game. But one of the variation is like the boxes are known. The position of the boxes are known, generated by some seed. You will have to mark all of the boxes in the least amount of steps. And now I don't know if I will actually have to do this, but and return to the home page to the starting point. Now the idea here is actually like you don't have to do this to mark all of the boxes in the least amount of steps, but you have to actually like. So let me just like if actually I will redefine this because this will be like a IOI style problem. It won't be like it won't be a problem where you have to mark it most optimally. But the positions of the boxes are known, generated by a seed. Then, what you have to do is the following. Let t be the number of steps, the minimum number of steps required to mark all boxes and return to the starting point. The minimum number of steps to require if played optimally. So this is the minimum number of steps required to mark all of the boxes. So go to all of the boxes, mark them, and return to the starting point. So let's say u be the amount of steps your program needs to solve the problem. Then the score will be, let's say, u over t times 100. So that's pretty IOI based approach. So you have something, you have this minimum this is the minimum number of steps required, and then your program does it in some other steps, and then this will be u divided by t. But the idea is that you have some grid, right? So I don't know if you can see this. Okay, you can see this. Okay, so you have some grid, and then there's like the robot here, and let's say that this is how do I actually R? Let's say R. This is the robot, and then there's some boxes. And all of them, like, let's say B. Now to mark a box, you have to go to one of the adjacent squares to the box. You divided by t times 100. Yes, I never mean to have like this. I mean to have like this, but the order of operations, the brackets still don't matter. So to mark a box, you have to go to one of the adjacent squares to the boxes and say that there is a box, like if you are, let's say, because the box itself, like you cannot go through the box. That's very important to the game. So if you're here, if you're at this point here, if the robot is here, you will mark the box as saying there is like a command which like you can call and say there is a box, or like mark a box to my right. So when the robot comes here, it will say mark a box to my right, or when the robot comes here, will say mark a box to my down, right? Or to my left, or to my up, right? So there are these 4 commands. So it's a little bit, it's not just a traveling salesman problem, but for each of the nodes, you have 4 different nodes where you can come. And then, like, let's say the optimal thing is to go to this node first, mark here, then to go here, mark here, then to go here, let's say, then to go, let's say, here, then to go, let's say, here, then to go, let's say, here, or let's say it's more optimal to go here than to go here. Let's say this is the most optimal path, right, for the robot to take. Now we need first to find the most optimal path, because the judge needs to know what's the most optimal path. And then the player itself will program the robot to do the most optimal path. Now, of course, the children game will denote will like move the robot with like for loops, or with like the most basic thing what the children can do is like say move right, move right, move right, like many times. But this will actually have a lot of code, a lot of commands what you need to put, right? So in order to score this, you can actually write a program that will score what is the minimum amount of commands you kind of, not commands but blocks, they call them here blocks, because this is like you have but because this is the whole idea of the problem. Like you have only 8 blocks to use to solve this problem. So if you're not doing it carefully, and if you're not doing it precisely, you will run out of these blocks. So what we can do is we can score not only through the amount of the most optimal path, but we can also score it about how many blocks we have. Shouldn't it be t over u times 100? T is the most optimal. T is the minimum number of steps required. U is more steps than yes. So it's more steps, which means that if it's the most, yes, that's correct. Actually, yeah. I'm sorry. I'm sorry. I did. I. Yes. Okay. I thought the other way around. I wrote. Yeah. That's correct. That's correct. It's the minimum number of steps. It's the last thing. Is the smallest thing from this here. Yes, of course. Um, so yeah, this is one of our scores. But there is a score about how many commands does the robot take. So we have to somehow incorporate this score, maybe with a weighting function, maybe with some like other thing. I'm not sure how we're gonna do it. But so it is possible actually like to do like if there are some configuration of boxes where you can like circle them somehow cleverly, it's possible to minimize this score, minimize the other score, the block count score actually. So there's like a block count score, and there's a lot of variations we can actually like improve, and we can track like a leaderboard of things like this guy is best at creating most optimal paths, right? This guy is the best at using the least amount of blocks to mark all of the boxes, or something like that, or some other idea. But not to get like overly complicated, we first have to do the traveling salesman problem, and we have to do this modified version of the traveling salesman problem. We have to do a UI to make it look good, at least, right? And to make it playable. So we have to program how the robot will like you have to give the user how the robot will move. So that's our goal. That's our goal for today. It doesn't. It's not. It's not too ambitious. Like believe me. It's just. I mean, we for the basic idea of the problem without any variations, without any. So just marking boxes, like most optimal path to mark boxes. I think we will solve this. So I need a name. I need a name of the game actually. Like how should I name it? Okay, I will just for now make a folder called TSP. But like if you have any idea on how like I need to name the game, or like maybe ChatGPT, ask ChatGPT about it. Maybe. So we'll have like a just a simple. I don't really care about design right now, but I'll just have like a simple HTML file with has like game. Now here I will let me just do a CSS file. again, and a JavaScript file, which is script.js. Let's say, let's include them. Let's include what is. I haven't programmed all styles.css. JavaScript source. What should be the name of the game? I don't know. Why is it like this? Script. So I need to say the following. So let me just reveal an Explorer pop-up. Let's open it up in Chrome. So let me just do background color, because I will do it dark mode, some gray, I mean not a gray color, but I can pick here, cool dark color, apply. Yeah, I know that something with the, how was this linked? Wasn't it? Oh, you need to do, I totally forgot the HTML. HTML, CSS, wow, I totally forgot the HTML. Yeah, oh yes, you have to do this. Yes, okay. Okay, HTML works. Now JavaScript, if I remember right, this I haven't done this since on load. I can add an event handler, add event listener on load, and then I can do this, and then I can log something in the console to test if my JavaScript is working. It's not. I think this is not. Oh, this is embarrassing. HTML, JavaScript, script tag, blah 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 blah. I actually don't program in HTML. Of course, I use Svelte to do my things, but here Svelte is not going to make. Yeah, I think this is right. I mean, is it not right that? So yeah, actually I'm right here, but the event listener add event window dot to add event listener. Oh, is it just load? Ah, this is insane. Okay, so we got it. Okay, now from here on should be easy. That's a overstatement. Okay, so that's an understatement or something. I'm not sure. So let's say we have some div. This will be our container. Let's say that this will be our game. Our game will be. Let's do this game. with like I don't know how to actually, like, there's no, but I will do container display flags with 100 VH width. So this is like saying 100% of our screen. Align item center, justify. Was it justify items? Was it align item? Not sure. But the whole idea, okay, we have some game and we have, maybe it should be like traversal solver puzzles. Traversal solver puzzles. Yeah, okay, we can, I mean, it doesn't matter. Like, let's just do traversal solver puzzles. I don't care, we can change it later. I'm not, I don't really. Let me just try here. So this is fine. I don't want overflows, so overflow hidden. That should be fine. Of course, color should be white. B1, B color should be also white. And all of these things. Also a better font, of course. Let's just font family. I'm not sure. Let's try to pick monospace, maybe something like, yeah, something like this would be fine. Okay, doesn't really matter. Now we should create the whole table. So there should be like a function. There should be like the grid. So the grid should be needs to be created. Is it fine? Is it see? Can you see it in like the? Is it so? Do I need to zoom in more, or so there's should be height and height. Let's say height is like 10. Let width again 10. Then there's width height. Then there's the number of boxes. Let's say 6. Then I need to create a function where create table, create grid. This function will take the game. So we have like two for loops. We'll have one of the height and one of the width thingy. And now, actually, let me teach you something. I mean, I probably know this, but so you can create HTML elements dynamically in JavaScript, of course, but so how do you pull this off? You do row is equal to document dot create element some div, but also document dot class name or class list. Class list dot add, and then I will say that this is a row. I will add it as a row. Then here the same idea, but this is like a now cell. This is my cell. Or I will just call it column. But also I need to add like the coordinates, so I can just just access this thing again later. How is this most? So first row append child cell, then I need to let my game container is document.get element by id game. Oh, it's not id, it's class. Say that this is the grid id grid. So game container dot append child row. Now I need to mark every cell with something, so maybe I will do it so that data cell dot. Was there a function document get element by class name, by tag name, by id? So I will do this cell dot id, and I will concatenate I plus something like this plus j. And now game container, now this should actually, now if I call create grid here, I should create a grid, but you can't see this grid. You see here there's these rows, and there's each column has 0, 0, 0, 1, 0, 2 to 0, 9, all of these. Now of course these are all with like infinitely small sizes, so I need to create here some styling for this, and essentially there's like the cell, or no, the column, we call it column, with, let's say, I don't know, 20 pixels. No, let's put it in IM, which is font dependent. This is, and then background color, blah blah blah. Let's put it some RGB color. Of course, not this. Let's put it some what kind of something like this. Some really interesting color. Okay, that's too small. No, and you need to say that display here flex direction column. Okay, and row, I need to say that row display inline block. Inline. No, it's not inline. Display inline. Yeah, display inline block it is. Okay, so this is kind of small, but I will zoom it. Maybe I will maybe do it to EM or something. Then I need border corner. How was it? Border 0.2 EM black. Solid black. That's too much. White. Maybe it's better. Cool. Maybe. Wait. What is this zoomed in? This is 100% zoomed in. So I'll make it like 5 EM. Maybe 5 EM. Maybe better. Maybe more. I don't know. I'm not sure how this will look. But whatever. We have something. Now this is our grid. Now we have to generate robots and boxes on it. So how do we do this? Okay, so we need a function, and we'll say generate populate or generate state, and then there should be a seed here. Now I'm not sure how JavaScript handles seeding. That's one thing. How JavaScript handles JavaScript seed math random. So math.random generates some random number, but is it possible to seed it? Because I need to seed it. When you're developing a game, it's very important to seed to have seeds. Because if you're testing it, you want to be deterministically creating state, deterministically creating state. Let me just turn off my. Let me just make my monitor a lot less brighter. How do you seed it here? Okay, let's get a random number generator. JavaScript random number generator with seed. There's some script that I can use. Okay, let's use this script. Okay, so the random number generator should be created here. RNG seed. Okay, well, let it be like this. So I can call my RNG and it will get me actually this, but I want an integer, so probably I can call my RNG other fast. Okay, it doesn't really matter. But actually, I want it here inside the function C. So RNG dot now RNG dot what was this called? Int 32. Actually, I want to make a function get random int, and this is between start and end and my RNG. So this is some random integer, right? Now we need to get this random modulo and minus start plus 1. This will get us in the something like this, right? So this will get us, like, if end is 5 and start is 1, then 5 minus 1 is 5. So this is like modulo 5, right? This is modulo 5, which means random goes from 0 to 4, then 1 plus this will be fine. So this is the get random integer function. Now we will, of course, our robot will be let robot x and robot y be 0. But there should be some field where this is like how was JavaScript or 2D arrays? Well, I haven't called it JavaScript. You're not supposed to create a 2D array. You're supposed to. I don't think there is a function where you create. I think you have to push into the array. there's no initialization that will create a 2D array. I think that's yeah, I think you're supposed to do that, which is stupid. Doesn't quite matter. Okay, so let's get the field. Field is some array. Then, because you have to generate this, you have to kind of, okay, let's say that we reset the field. Field height width. We'll denote them by zeros, and then we will let number boxes is 0 while number boxes is smaller than boxes. Try to generate x coordinate get random int between 0 and block and height -1 with our RNG. Let y get random int between 0 and height minus and width -1 with our RNG. We have x and y. Now we have to check if field of x and y is 0. If there's no population there, so if there's nothing there, we can put a box. Also, we have to do field of 0, 0 is actually like where this our robot will be. So let's say rx, ry. So let's say that 1 is our robot. If it's 0, then I can put field of x, y is 2. Let's say that the boxes are 2 denoted by whatever, doesn't really matter. And then number of boxes plus plus. So that's one more box put in there. Okay, cool. Now we have to draw the boxes. So when we generate the state, we generate some state. Let me just console log what our state is for now, and I will generate the state, and the seed will be some like random thing. Doesn't quite matter. Let me see if oops, we're probably in this loop here. Math seed random is not a constructor. Wait. Oh, you have to include it. I forgot about that. You have to include it before our JavaScript because file not found. No, that's HTTP here. Or HTTPS, is it one? Yeah, so we have some array. There are all zeros except this one. This guy, now this should work. This should cannot read properties of -3. Wait, -3 start plus random. Oh, maybe this is whoops. This can be negative as well, probably, because it's signed integer. Quick 32 randomness in float. How do you get an unsigned integer? Maybe just an absolute value. Let's just call it a day with an absolute value. Okay, cool. Now we have some boxes here. Okay, now we have some boxes. We need to draw the boxes. So we have to have a method function draw. Draw will get some field, let's say f, and we'll go over all of these. Height, width, if f at I, j. So first, if it's a robot, we will say that, so this is the idea. Left cell is document get element by ID, and this is our ID, which is kind of cool. So this is our ID. Then we have, so cell dot children, cell dot child nodes dot clear, or no, dot children dot clear. Is that possible? I'm not sure. Not sure how to clear the children. Dot child clear all child elements. Inner HTML, okay. Cell dot inner HTML is this. This will clear the child elements. Then we need if fij is equal to 1, that's a robot, so cell append child, and the child that we're appending will be a robot icon. So there's, a robot icon with let robot be document create element. So some image, we have to find an image of a robot. And also a box, we need an image of a box. Else if f of j is equal to 2. So let's say, or can we just, maybe for now, just create like this. So robot dot inner HTML is R and B. So this could be fine. Draw. Now draw field. Why did it make here? Robot is not defined. Box. Okay, but why did it shift it like this? Oh, maybe span, just span, because diff takes. That's weird. What about this cell? I will make it look better afterwards. Wait, what? How? What is going on? Okay, I will make all rows display flags so it just doesn't. This will fix the problem. Okay, so all columns font size will be like, I don't know, 5 even. No, not font size. Oh, font size makes it for changes the font this. So let's say that robot dot robot dot class list dot add icon. Then I can do icon font size. Yes, okay, that's for now. Okay, what about if I do flex like this and then I do a lot and I copy this? This will align them all to the center. Okay, it doesn't quite really matter, but we know where the boxes are, where the robot is. Now we have to do Traveling Salesman. Okay, every time we generate this will be the same grid because our seed will be this here. If I change the seed, I will change the grid, which is really nice because I can experiment after I actually so I know every time will be the same. Okay, cool. Okay, let's do now Traveling Salesman Problem. How do we? I'm so bad in Java that I'm not even sure that I'm capable of Java. This is not Java. This is JavaScript. I'm not sure even capable of doing the Traveling Salesman Problem here, but I will try my best. So Traveling Salesman Problem. Well, web transport travel. Let's say TCP traveling salesman. I first have to know where the boxes are, and I have to compute, not void, there's a function here. I have to get where the boxes are, so that's, okay, so I need an array, I need an array of where the boxes are, so I need let boxes, some array, and then I need to iterate over the width, over the height. If field of imj is a box, then boxes dot push, and then I will create access I some object where x is I, y is j. I have the boxes. Essentially, I don't really need the box. I need the directions of each box. So there are 4 directions of each box. But some boxes when there is like at the top like this here, this direction won't be valid. You cannot come here. So, but still we will make all of these 4 directions. So let there is 0, there is up to 4. Let x is I plus dx of there. It's like the same as C++ in many cases, but there are some things that annoy me. I need to create no, it was just const dx, and then you do this. If you want to have a const. Okay, so you iterate over the 4 directions, then now have new boxes, push x is new x, and y is y. So, no, y is ny. So you have this. Now there can be invalid, but I won't care about that right now. Now we need a DP state. The DP state will be, okay, our DP will be where I am. So the last thing I visited, the last, not thing I visited, but the last, like, all these 4 directions can be one of these last things I visited. So this is like the last adjacent thing I have visited. And then the mask is what boxes have I marked down. So the cost of visiting, of marking all boxes in mask, ending up at ith adjacency point. I'll call this adjacency point because I don't know how to call it some other way around. So like in mask, ending up at adjacency point. So this here is adjacency point because this is adjacent to the boxes. Points maybe. So at the ith adjacency point, there's 4 times m adjacency points, and there's 2 times to the m boxes, to the m masks. So how were you supposed to, like, I want to write iterative DP, but I want to, first I need to create this DP. So how do I create this DP? So I created let I be from 4 times boxes. Let j be from 0 to 1. There was some resizing function that I can do. I'm pretty sure. I'm pretty sure you could do like an array here and then array length. You could do it as like array length, which is like 1 to the boxes, but I will still need to fill it. Maybe I can fill it here. Not sure with what is it filled. That's the point. Okay, let's say that this is our DP. Let's just console log our DP to see if that works. Let's say TCP. No, not field. DP. $64 to the 6. Okay, 64. There's 24 of these. Okay, cool. Cool. Now DP works. DP here. I mean, this initialization works. Now I need to say that I go through each mask. Wait, traveling salesman problem, like you go first through the masks or you go first through the boxes? You go first through the masks, right? And then you say for each box, yeah, you say that, okay, so if mask is 0, it means that you have never visited there. You have you have never marked anything, right? Then you go for let last is like 4 times boxes. But also this has to be inside this node has to be inside the traveling salesman problem, right? Yeah, Blog, I know recursively, yes, but I don't like it recursively because if I implement it now recursively in JavaScript, the thing is that JavaScript will like eat up stack memory on the computer, a lot of stack memory for the. I mean, not a lot because there's only the depth is not a lot, but still, I don't prefer it recursively. It's slow. JavaScript it's slow, and recursively it will be like even slower. So I want to make it iteratively. But adjacency points also has to include that's a thing you have to include in adjacency points. Adjacency points have to include the robot X and the robot Y. So that's one thing you have to include. Also, because when you're starting from here, you end up you go somewhere, and then you kind of and also we kind of need a BFS, right? Because to know the distance between any adjacency point to any other adjacency point, it's not just straightforward doing this. Sometimes you need to go over some point, right? So like if there is a wall of boxes here, you need to go over the wall of boxes like that to come to the other side. So it's not a straightforward problem, even if you call it as like a competitive programming problem. So it's so we need to do a BFS here. And first we need to create a array where distances will be called. So distances for each from the one of the boxes plus 1 actually. So this maybe I will do it in let n equal to this. So I don't all the time write. So for each of these, I have to do a BFS here. Hope this is much more complicated. Especially BFS in JavaScript. I don't even know how to do a queue here. I may just do it with pointers. Let me just think about this. So distances. Okay, so we need to populate distances. Distances at I is array at array with n, and then you have to say that the distance. Oops. At ij is equal to some big number, if I equals to j, distance at j is equal to 0, else this. Now we do a we do from every starting point to every ending point. We do what is the distance. Distance is BFS at ij, something like that. And now I have to actually not at ij. We need to do adjacent points at I and adjacent points at j. So from this corner to this corner, we need to calculate the distance. Now function BFS point P1, P2, 2 points. We start from P1 and we go to P2. Now how do we calculate the distance? We need again some kind of array. So and again it's stupidly. Of course you don't need to do it quite cubically. I can compute it from every point to every other point. I can do this. Every point to every other point. Distance at I. So I don't even need to do this. But whatever, I'll do it anyways. Now here is like a distance array, and then this is actually not through n, but like through width, no, through height, and then width. So this is okay, and then we need through every width distance of I and j to be infinite. Now distance at p1.x, p1.y is 0. Now we need a queue. How do we do JavaScript queue? I won't implement a queue, dude. Like, are you insane? I want to implement a queue. I'll just label lists. I'll just do this. Yeah, like it's totally insane. I can just do this. Push to a list something p1. I will do this p1.x. I mean, I can push p1 as well. I can push p1, and now I can have like queue size, or no, I can have like p, which is 0, and then while p is smaller than q dot length, let top be q at p plus plus. This is essentially saying we're moving this pointer. I'm not going to delete anything from the list, just to make it quick. I'll delete the whole list at the end. So that's the top thing. So I will go for each for the directions again. Top.x plus dx there, left and right. You know that what I'm doing here, of course, doesn't it's not required by the faculty, of course. No other student will like write TSP, Traveling Salesman Problem in JavaScript just to create a simple game, right? But it's kind of fun to actually challenge yourself much more than what you're required to do. So you have top Y. So I need to check here if this is possible actually. NX NY NX height NY width. Okay, so if that's possible, it's cool thing. Yeah, I mean, thank you. I hope it's going to end up interesting project at least, right? Some interesting thing. So NX and Y, you have this. Now what you're doing? So you check. Okay, so this is valid. Now you have to check if this field is valid. So if field of NX and Y is empty, there you can go. I mean, it's not the field should kind of not contain the robot itself, but whatever. It doesn't matter. If it's not if it's not the box, you can go there. So if it's not the box, you can go there because the box won't move. So we kind of need the distance. So and the distance of NX and Y is bigger than the distance of top X top Y plus 1. Then I can move there. Oops. Top Y plus 1. And I will say that Q dot push X is NX, Y is NY. So I push new coordinate to the Q. So the length of the Q should gain and then should repeat this process. Now we have all the distances through each of the other points, right? Now we kind of wanna extract only the distances at the adjacency points. That's what we actually want. So adjacency points at I, but so I will actually maybe put like adjacency points itself and then I. So here I'll have adjacency points and then what is my I? So let P1 equal adjacency points at I. Then for all of the other adjacency points, so for let I from 0 to adjacency points length, now I have to have a result. A result is some array which is for each adjacency point. Big result at I is the distance to this adjacency point. So adjacency points at I dot x, adjacency points at I dot y. So that should be the result. And now the result should be here. So that's a n. What is this? N squared. It's not n squared. You're going through the whole matrix. It's n times width times height or something. But doesn't matter. That's too fast. So we have the distances. I need to console log distances to see if I got it right. Can't set property setting element 2. What is this? Distances at P1, P1. Okay, so distance is something not calculated here. Distances at this, distances at array is width. this array is with what setting up cannot set properties of undefined. Oh, what if the point? Oh, I never look if the point is actually inside. If p1.x is p1.y, p1, because some points are not valid, but that's okay. I will leave them inside the loops because it will be hard to deal if it's p1.y. No, this is width. This is height. So if that's the case, then I will return an empty, I will return a array where this is like, where all of these results are like infinity. That's one thing we need to do. Another thing is we need to test here also as well. So let x be adjacent points at I dot x, let y be adjacent points at I dot y if x you're gonna say result at I is distance at x and y, else result at I is infinity. Also, okay, so this is fine. This is x, y, x, y. Maybe we should have made a function here valid or something, but that's okay. Oops. Still I'm setting invalid points. Still I'm setting invalid points. How is that even possible? p1 dot x is bigger or equal 0 p. Yeah, wait, if that's not the case, that's not the case. Okay, cool. And then this array is like the distances array and says that point 1 is invalid. Yes, because point 1 is this one here. Then the other points are having all of these distances. That's pretty cool. Okay, our BFS works. I will clean this code off camera because now I don't want to lose time cleaning up this code. So our BFS works. Now it's to create the traveling salesman problem, the DP. Mask points. So how are you supposed to do the DP? If the last point here, the node is represented as last divided by 4, because each of these will divide like this, but then this is the first node, and this is the second node, and this is the third node, and so on until the n plus 1 node. Now this is the node where I am in. So if I have already visited this node, if mask and one of the nodes, oh, here the nodes are actually boxes plus one. Oh, we should not forget about that. And also here there's like the DP is first and first, yeah, it's the boxes. Yeah, it's the boxes is like, okay, so instead of and I'm going to do let m be the boxes plus one because this is the amount, this is the cities here. Let's m. No, wait. Like this. Because I have one more, well, I have the robot itself I need to account for. So all of these are dead. So if it's already visited, what does that mean? What does that mean? So if it's already um I haven't looked at TCP for a long time, but let me figure out. DP of I, if it's already visited, then I can skip it probably because I won't need to visit. I'm not supposed to visit it again. But if it's not visited, yes, so if it's not visited, then DP of last and mask and this node is math minimum. So I'll just do a I don't want a reference function. Math minimum of DP of last and mask at this node. And DP of last mask plus the distance between no, you're supposed to, is it 2 to the n times n squared? Because you're supposed to be at some node that you're last visited, but you're supposed to visit every other node, right? Is the solution 2 to the n times n squared? Or can you bring it down? Travelling Salesman Problem. Can you bring it down to 2 to the n times n? Yeah, 2 to the n times n squared, right? Like, because you have the what I am here and what it is next node. Yeah, thank you. Yeah. What is my last node and what is my so what is my last node and what is my this if this is so this is the next so this is next node, this is last node, supposed to last node. If the next node is already it's not visited, then this is we are visiting the next node, and this is here essentially next is next mask adding this node, which is what I'm the next node. It's the same thing as adding this. Let me just make it more clear here. So it's the same thing as this, or what I'm the last node, the mask, and this is the distance between the last node and the next node. So nodes only go up to n. Nodes only go up to boxes, but last node goes up to n. Yes, this goes up to n. That should work. Oh, why 0? I don't say that dp of mask of wait dp of last node is what is the last node supposed to be? Last node supposed to be my starting point, which is n minus 1. This is my starting point where the robot starts, and I have not visited nothing. Okay, there are some shenanigans here. I was expecting more of these, but maybe there are a lot of masks, including this node, which cannot be accessed. I mean, there are shenanigans, so... Okay, so we kind of have the DP, and then we need to know that what is my DP. So this is without returning at the home base. This is very important. So, but let me see how many, what is the smallest DP. So I go over all of the what is my last node? What is my last node? And let best is like infinite. Best is math minimum of best and dp at my last node, and the mask is 102 m minus 1. M is the amount of box plus 1. This is the thing. Console console log best dp best 13. It says with 13 moves. Can you really create with 13 moves? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I can create with 11 moves. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, that's not right. Okay, let me check our salesman problem. So we go up to M. This is the boxes plus 1. N is how many of these we account for, like the adjacency points around the boxes. This is the last, this is the next. If they're equal, I don't care because I won't spend time there. Last node and next node. So if the next node is already visited, dp at this next node is the minimum of visiting the next node through some other mask. And the dp of visiting I'm in the last node with my mask, and the list distance between last and next. What if I do this? Oh, now it's 11. So last equals to next. You can maybe come to the same node, but okay, I don't understand, but whatever. So now it's 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, cool. Cool. Now let's mark all of the. Okay, so we have to I think we have to kind of show what's the optimal path. To have like a function that like draws the optimal path. Just to test it out maybe. So how do you draw the optimal path? So let's have a list here, optimal, and then we start from the best here, from what is the best at the last node. So if best ID maybe, best last, if dp of best last, if dp of last is at m minus 1 is smaller than dp of best last at m minus 1, then best last is last. So start at this point. Also, we need to know the parents of all of these points. So where should we go next, right? So it's like dp of past last. This should be the same. This should be the same. Yes, this is the same 11. Now, how to find the optimal path is to remember the parents of the points. Let p parents. How was the... Let's say parent. Parent at I equals array at this, parent at ij equals 0. That doesn't really matter. Now you have to remember the parent here. So let new dp. I don't know how referencing works in. I don't think you can do referencing like that. It would have been amazing. Let me learn about reference variable. Pass variables, not pass variables by reference. Passing variables by reference is another idea. Reference to a variable. I know that. Pointer. Yeah, there's no pointers. I mean, under the hood, yes, but like this, no. So that's dp of next mask next node is bigger than. So if this is smaller than that, or the other way around, maybe it's better, right? Bigger than that, then this is that, and the parent, I'll just write PR because I want to make it equally lengthy. PR at this the parent at this is last. So now that we have the parents, I can say while p is not 0, p is parent of p and mask. Let mask be 1 times n minus 1, and then mask is going to be equal to mask and 1 to is this right? No, 1 to the alt p. This is alt p. I think this is the reconstruction. So you have alt p is the parent of the mask, this, and then the mask is added without this here guy. And then when I have this, it's like I do optimal push P. But also I have to do something else, but let's just console log optimal to see if that works. At least. Invalid array length. Invalid array length. Where is this? 200. Wait, what? P. Am I using P somewhere else? No. Optimal push P. Oh, maybe the while loop is not right. That could be it. Yeah, let's console log this. $127. That's not right. Alt P. Wait. Come on, don't crash. Don't crash. Come on, Chrome. Ah. Don't crash. Unbelievable. 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 Let me just open up, restore this. Because I want to see the chat. What is this now? Okay, let's open it. Okay, now it should be fine. Let me just pull off this. So that's oh, I want to say this. So let mask equal to 127, right? Mask and so can I do this? 1 to like 4 is this, right? This is minus 17. Then mask and this works, and then mask equal this, it works. Oh, what about the if the parent is not? Oh, that could be it. Oh, oh, I see. But if the parent, what let's say if all parents are -1 by default. Well, the parent is bigger than 0. Maybe the parent is what is. Why isn't YouTube loading chat? Log p. Oh, maybe there's some point in 8p. No, there shouldn't be a point in 8p. Instead of while, let's do a for. Parent 13, 22, 13, 22, 13. Oh, maybe it is. But wait, when I do the mask here, I should get a smaller mask. Why don't I get a smaller mask? What? How is it? No, up to n. Up to n is the last thing I need to. Oh, of course, I have to divide this. Oh, yes. Of course, I have to divide this by 4. Yeah, so now the mask goes down, and then the parent comes to this. Yeah, so now the optimal thing should be optimal push p. Now we have some optimal things. So we say we come from the 13 point to the 22 point to the blah 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 blah. And now because we have all of these points, we just need to mark them. Let's mark the most optimal points for let point in optimal of optimal, I think was the idea. Document.get element by id point point dot point is, so you have to x is adjacent points at point, x let y is adjacent point dot y, blah blah blah, x plus this plus y. So we get this element, and then on the element we want attribute style dot background color, and then let's put just red to know. So yeah, that is correct. So I go here, I go here, I go here, I go here, and I go here. So that's the optimal marking spots where these are. Cool. Yes, that works. Okay, let's try. Let's copy this seed and let's try some other seed. Mark, then mark, then mark, then mark, then mark, then mark. That's correct. Yes, yes. Mark, 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 mark. Okay, cool. Mark, 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 mark. Yes. Yes. Cool. Let's go back to that seed because that seed has this point here. Okay. So now we know the optimal path. Now we know the optimal score. I mean, we don't care about the optimal path, like for this. I mean, we can draw the whole optimal path later, because it's gonna be a little bit pain to draw this. But whatever, it doesn't matter. But the whole idea is now to allow the user to play and see how much does the user scores. Mm, and this now has to require a little bit of other type of engineering, and this is where okay, so cool. This is where Blockly comes into play. Blockly is like this thing here with like the blocks, but it also like it just JavaScript and it allows you to create your own blocks. So like you can create like your own blocks inside, and like you can say that move right, move left, mark up, mark down, blah blah blah, and then you can animate across this. But what I have to do is I have to go and I have to grab GitHub. I mean, probably here there's some link to GitHub, or I don't know, GitHub Blockly. That thing I need to download, download zip. Let me put it. Where should I put it? Here, GitHub develop. There's also, I mean, I don't really need this. I need Blockly samples actually. This here. I need Blockly samples. Please download zip. Blockly master. There's some examples that I will just copy here, and our professor showed this example. Let me find this generator demo. I think this was the example. You're just supposed to copy like this package JSON files inside this directory. We open up the terminal. So the package JSONs are just some files. It says the npm installer what to install. Essentially npm install this. That should be fine. I need to add just oops. I need to add code more. Want to ignore the modules. Actually, I can't. I mean, oh, okay. I will make it later. This, I will fix this later. I need to make a. Oh, this would be pain. Okay, I will fix it. The generator demo, essentially what it does is like, so it doesn't work because I don't have it installed here. But I will want to open this up. Oh, we need to extract this, that's why it doesn't work. Just see here. It should be fairly easy to code your own blocks, like I'll just copy and paste some stuff. Samples generate more. So you're supposed to put this here. Like you're supposed to add these things. Then blah blah blah. So this defines our toolbox. This defines our toolbox. This defines our starting blocks. This defines two functions. Run code and show code, and then there's evaluation for the code. So I can copy the whole script. I think I can just copy the whole script and I can paste it here. Now we should see something down there, but did it crash? No message string for arithmetic on the right. No, this should be inside another container here, but let's just try this. Okay, so we have this. So but this doesn't work fine. Let's see why it does. Node modules, blockly media. Addition symbol, subtraction symbol. This is some kind of I will assume this is incorrect. Blockly media. Blockly media. This should be correct. But the block text print block is missing text connection. Oh, maybe we're supposed to add something else as well. Maybe we're supposed to add this as well. Yeah, okay, so now it works. Yeah, so we have some functions here, but we'll add all of them later. And we'll add this. Now, I want to make this on the left side, so kind of this script I will copy here and I will make another file, or maybe inside this script as well. Does this work? Okay, this is supposed to work if I do the following here. Ah, get top blocks. Maybe I need to add all of them here. This works. Now let's make it a little bit more beautiful by adding a div here, class row container. Let's make this row container, display flex. What is this? Flex direction row. Of course, this doesn't quite look good, but we can add another here. Blockly container. Let's add this like that. Make it beautiful. Let's make this justify content center, align item center. Then I'll say blockly container margin to em. Okay, now the container is very small. Why is this very small? Also, I don't like that this like can, is it possible to make it dark themed? Blockly dark theme. I don't like it. Ugh, I don't like to build it with themes, Blockly. Dark mode. Yeah, but you need to import this theme. Theme, dark theme. But you have to import this. Okay, I will leave it. I will fix it later. I will make it dark theme. Okay, nice. So now if I run this show thingy, show code is not defined. No, show code is defined. It's just not defined. So show code. If I do show code workspace is not defined. How is that defined? Okay, now it shows the code for the JavaScript of this program. Now the idea is to where did it wait, what? Where did the boxes go? I don't know what I'm doing here. Blockly div, the toolbox. Oh, the toolbox is not defined here, of course. But I will define like the whole toolbox, doesn't mean. So now our blocks should be defined as there are some loops here, there's some math category, there's this text category, there's this logic category. So logic, loops, blah blah blah, these are all easy things. Okay, so when we have the code, the code, we have to evaluate it. And now the evaluation of the code is, so this thing here gives us some code, and now the code has to be evaluated. So the code to be evaluated, we have to do some functions first. We have to create some functions, and these functions will be, we have to create a function for everything. So for moving the robot, so move right, function move left, function move move right, move left, move up, function move down. So this function will do r y plus plus, will has to, each function has to call the draw element here. Is it, wait, I'll just close these two here. The draw element will, the draw element draws from the field, but we kind of want to have a function render, and this function we need to copy the field. Maybe we don't even need to copy the field. What we'll do is we'll make it if I is equal to Rx and J is equal to Ry, then this will be our robot, and then this doesn't move. So render, so this could be draw field and should be fine. Move left is Ry draw field. Move up is Rx draw field. Also, we have to check if Rx is -1 is bigger than 0. If Rx -1 is smaller than 0, we're gonna just return this. If R -1 is smaller than 0, return. If Ry is +1 is bigger or equal to the, what is this, width, return. And this is the same idea here with Rx to the height. These functions will move the robot and redraw the field. So if I reset and if I say move left, move right, move down, move right, so that kind of works. Okay. So another thing is we need to mark. We have some functions to mark. Function mark up. Essentially, we're just going to do this again. Maybe we should have like another file for this, but I will fix it later. It's just not so clean code. I don't like it. Move up, move down, move right. Mark. Mark right, mark left. Mark up, mark down. Now marking a box will probably just, I will make so that the box just disappears maybe. Or just like changes the color, like green to green, like behind of the box changes the color. I can do that. So field at Rx Ry +1 is like 3. Or no, it should be 2 again. I'll just I'll make maybe another function that says Rx Ry +1. That would be mark. Just mark the color there. So another function here. Function mark xy. If field of x and y is box, then document.get element by id x plus y is dot style dot background color is green. So if I go and if I try to mark right, shouldn't work. But if I try to go move right and then mark right, should work. That's pretty cool. uh, I need a function where it checks check and uh, check and has to iterate through all of the boxes and see if they're all marked. Height if field j is 2 and now I should maybe I don't want to change the field because changing this will make the redrawing step worse. No, I will change it. I will change it to 3. If it's 2, then console log fail, return console log success. So I'll change it to 3 here, but on the draw method I need to change it either to 2 or to 3. So if I go move right, mark right, oops, I deleted. I need to say field xy3. Move right, mark right. That works, and then right, mark right, and then check, and that should fail because they're not all marked. Also, each time we move right, left, the count should increase. So, like move count should increase as well. Okay. Cool. Now we need to do the boxes here so I can. Okay, I mean I can do this off camera. It's not that important. I want to make the statistics so like you generate. So these are. I mean, let's say like this. First, I'll do this. There's so much implementation here to make this good, but okay, let's play around with blocks to evaluate some code. Evaluate some code. There is a way to do this. There is an example file where you have what example file was it? Kicks demo? What is this? No. Maybe toolbox demo. No, it was something easy, something easy. So here, what kind of blocks do you have? These are the already implemented ones, but there was a way how you can. There was a demo which I could copy just something here. Maybe there wasn't a demo. I don't know. Google developer Blockly. So see, these blocks here are directly transpiled into JavaScript. So you could create your own. You could take. So this compressed. No, I don't want. I mean, wait. I can take a look at some other demo. Sample app. Sample app. Yeah, so this blocks and text. So yeah, this could be it. Sample app. So the generator. The generator for each block output something. This is way too complicated. Custom tooltips, custom toolbox demo, starter code. Let's see if that is interesting. It has a lot of variables. Yeah, toolbox definition, body unload start. So there's toolbox definitions. I can copy this and I can put it here somewhere. So there's toolbox definitions, and then there's so the workspace is just this. Cool. So I think this would work. I think this would work. Right, TCP script. Now I'll need this toolbox here. Oops, let me just close this. Start your blocks. Just okay, let's see now. Okay, now we have all of these here. I will delete the things that I don't need. But this should allow us to generate code. This should allow us to generate code. Let's say that we have some if statement. Let's say that we have repeat. Can we show? Yes. So if false, repeat. So it kind of generates some code. So to run this code, you just evaluate it, right? But you want to kind of create your own blocks here, and I'm not sure how. Now, how do you create your own blocks? Explore, create custom blocks. Custom blocks. Yeah, so here block type, let's say move up. There are no inputs. There are no connections. Tooltip move up. Tooltip move the robot up. Some color. So wait, I have to actually do a dummy input somehow. Dummy input. No. What was I supposed to do? Value input name, statement input interval. Dummy input. I am supposed to put dummy input. Right? So no connections, move up. Maybe I'm supposed to put some text here. Oh, you're supposed move up. Aha, okay, so you're supposed to, and this is our block definition. And you kind of need to do this for all of these. I don't remember how you add the block exporter. Save, move up, block line, block exporter, export, file name. Okay, blocks generator. Now we have blocks. So I'm supposed to put this. If I have move up, I will just copy it many times for the other directions. Move GitHub, no. This. blocks.js. No, here. Then allow, and then generator.js. Okay. Now what is, wait. So this is what, how does, wait, what? That's, oh, you're supposed to select it. Well, okay, doesn't matter. Can I just copy it like this? And then the JavaScript generate. So here I will just call the function move up. Or just return move up. This will be my function. Now I need to kind of sign these blocks. I need to import these blocks. That's blockly import custom blocks. Add custom blocks. Blockly.define this. I need to call blockly.define this array. Okay, format document. Okay, that looks good. Now I need to kind of call this generate. But maybe I need to function define generate. And in blocks I also function define blocks. And now I need to make them first, and in the script I need to call define generator define blocks. But now in the blocks section move up, but maybe, oh, I need maybe to do it also here. Category robot. Category robot. Move up. Was the block defined move up? Defined move up like this. This doesn't work. Oh, I'm adding into a wrong HTML file. Cool. Oh, nice, nice. Now we have the block, and now if I show the code, it just shows move up. Yes, that's excellent. Now I need to do this for move down, move right, move left. Let's just add underscore maybe for all of these, and then like. If I reset, I won't find the definitions of the blocks until I actually do this. So each of these blocks, move right, move down, right, left. I'll need to fix this as well. Down, right, left. Move the robot up. Okay, so now this should. I need for markdown as well. Markdown. You can find, move, mark only in selection. Where is this only in selection? Or maybe I can just. No, I wasn't meant. Well, this. I'll fix it later. Invalid block, move left. Why did I? Wait. Move up, move. Okay, I have them all. Now the generator as well. I need to copy this thing here. Essentially what I can do is I can do like this. Let commands be move up, move down. Actually this, let directions is up, down, left, right. Command like this, and now here as well I can do this. Move command at there. Now I need to capitalize this. Is there a function capitalize? Dot split. Dot split. Dot slice. start is 1. Or I can do this cap at 0 is cap at 0 minus a plus a. I think I can do this. Not sure. Command cap. No, that doesn't work. Uppercase, maybe. Yeah, of course, but of course, yeah. I will just. I mean, I will finish a little bit more, and then probably I want to make the code execution work so I can upload it and uh, can like you can try playing around with the code execution, even though I will need to fix some things but I want to make it just so I have a game that I can just host it. But yeah, good luck on the test tomorrow. So yeah, let's see, to uppercase where this command console log. Yeah, good night. I know that you will just you will take them down, so it's no problem there. The uppercase. First letter JavaScript. That's some stupid ideas in JavaScript. I can't yeah, whatever. But now that should work. Yes, that works. Now we have to copy it for the markdown as well. So we have to have mark as well. That should mark down something. Okay, so now we have move and mark up, mark down. That's cool. Now we have to just implement the animation, and that's it. We're done, I think. Okay, let's do this. So evaluation of the code. So evaluation of the code is like already will work, but my idea is to on each of these I want to kind of sleep a little bit. So how to sleep in JavaScript. But if you sleep, you will just oh. So maybe like this, maybe sleep here, and then return new promise, resolve after some seconds. Now on every of these, I want to sleep. I want to await sleep 1 second. 4.5. Sleep between. Now, because these are not async functions, you have to make them async. All this is in milliseconds, so that's 500 milliseconds. Now, all of these have to be async functions. And all of these have to sleep at the end. But now, because these are async functions, we have to also, while generating the code, you have to also await. And you have to also mark that in a sleep loop. Code is JavaScript. So I have to make it in a function. Function call. Function run robot. Async function run robot. Oh, I can do this. Async, and I can do this, I think. Yeah. So if I have like mark right, I can show move right. Okay. Then move down. Oh, I need to tell him to make it after. Oh, I forgot about this. There's some way to tell them that there's something after. Hmm. No, I'm not supposed to do that. Yeah, you're supposed to do top left. So there's previous statement, next statement is no. This is supposed to be added. Yeah. So you're supposed to add like this. So move up, mark right, move right. Like if I show it, it's fine, and then if I run it, it works. Yes. Okay. Cool. Essentially, you have this. Now I want to make it. I want kind of to limit the categories. Logic. I mean, I won't limit it for now. Maybe just color. I don't care about color. Probably stupid. Variables and functions. Okay. So you kind of have the robot show optimal. I will add a button that will say okay, this I'll show optimal. Show optimal markings, and this should be function show optimal markings. Is just so optimal is here. Show optimal markings is just do this. You don't see the markings, but when you click the button, change point is not defined. Ah, show optimal works. Okay, this works then. Okay. So this works now, we have to evaluate it. Got score of what is the optimal DP? optimal score will be written here. Optimal score. And then optimal score. Now the score that you get is optimal score divided by move count. Move count times 100 points. Now let's do a small amount of boxes for starters. Let's do 2 boxes. Okay, and let's do so. Show optimal markings. Oh, this I wouldn't have gotten. But I guess. So you could do loops, repeat, move right. 1, 2, 3, 4. 4 times move right. Loops, repeat. 2 times move. Mark right, mark left. Now we have to check at the end we have to add a check. We have to add check and can I so like is it is it possible to export code and then to have this all the time? So I have to start blocks, blockly start blocks. Okay, that doesn't make a lot of. Let's do it one more time. Repeat. Is it 4? Repeat 2. Move right. Mark. Got 100 points. Okay, let's try something else. Let's say move down, repeat 3 times. Move. Oh, move down. No. Ah, okay. To reset. Need to make a reset thingy. Also, the robot show's supposed to move the box where it. That's one more thing we need to add. It's already 3 hours, so I will add it off. I will add some things off camera, and then I will publish the. Probably tomorrow I will publish the game. I will add a few more things off camera, but that's pretty much the game. So yeah, thank you everyone for watching, and I'll see you in the next live.